Here we go. Hey everyone, welcome to the HR MacMillan Space Centre with another edition of Ask an Astronomer. I'm Michael here in our Ground Station Canada Theatre, located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh. And since this is Ask an Astronomer, we have brought in our astronomer, who actually is also in the building upstairs on another floor, and that is Rachel Wang. Hey Rachel, how's it going?
Good to be on site.
Yeah, how does it feel?
Feels unfamiliar almost.
Yeah, you have a very very brick, I guess, sort of like a walled wall behind you, as opposed to the digital background
The
of your
usual
home.
outer space. Yeah.
The usual outer space. But we are going to get into lots of really big topics. Of course, all month we've been talking about one particular planet in our solar system. It has been the biggest space news, and that's pretty much going to be the focus of what we're going to focus on today. Because even though last Thursday we did a whole session, a whole cosmic night, all on Perseverance to Mars, of course, that's when it landed. And even since it's landed, we've had so many things to get into, pictures, even some sounds, lots to get into when it comes to Perseverance. How are you feeling about Perseverance and Mars over this past month?
I think I'm still riding on the excitement from it because when I was watching the video and seeing all the NASA employees jump up in excitement, I felt like I was almost part of it, even though I didn't work on it. But it was a really nice feeling to see that all their hard work paid off.
Yeah, that's really interesting that you said that you felt that you were a part of it, because that afternoon I was on CBC News and they kind of had me there, kind of like on standby, asking me questions. And of course, like I'm listening to it and I'm like getting really nervous, because what happens if if it fails, and then I'm going to have to like answer these questions. That's like not going to be as fun, of course, to
Yeah.
like talk about, the failure. But as a Canadian, like we're not part of NASA, but for some reason, these missions to another planet do feel like we're part of them, because we are all sort of like this human species going to another planet. And even though we didn't work on this particular mission, it does somehow feel that all of humanity is going to a different planet. At least that's how I felt like in the moment, getting super excited to see another rover on Mars.
Sure, it doesn't matter what country gets there first. It's just knowing that it's possible to land on another planet and have rovers exploring another planet. I think that's really, really cool.
And of course, it isn't just NASA. We also have the United Arab Emirates with the Hope Orbiter, as well as China, Tianwen-1, which we will be getting into perhaps in a few months when their lander is going to be going down to the surface of Mars. So lots of activity on the planet of robots. So Rachel, let's get into some Perseverance news. And of course, everyone out there watching on YouTube, hello. Why don't you drop us a little message in the chat? Let us know where you are watching from on this planet. If you're out there watching a telescopic, hello to you. Come on into YouTube and join our Ask an Astronomer every second Thursday. So Rachel, a lot has happened since the beginning of the month, and of course since Thursday when Perseverance landed. Immediately we started to get some images, but also over the course of the week we started to see video for the first time, and this has just been incredible. We have never sort of like seen video this quickly from a Mars rover before.
Yeah, and the one that I'm most excited about is watching that entry, descent, and landing, that 7 minutes of terror from the eyes of Perseverance, which I thought was incredible to see.
Wow. So why don't you share some images to sort of show everyone, if you haven't gone to the NASA websites, let's just go through some of the highlights of the Perseverance mission.
Alrighty, here we go. So you should be able to see the NASA webpage, and I want to show you first that video that I was talking about Perseverance entering into the Martian atmosphere. So here we have the parachute deploying, and recall that this parachute is the largest parachute deployed on another planet. And we are beginning our descent into the EDL, the entry, descent, and landing. That 7 minutes of terror that NASA employees have are on the edge of their seat. So what you're seeing here is a heat shield being deployed, because even though the Martian atmosphere is very thin, it still has a lot of heat generated, and we don't want to fry any of the components before we got in there. So there goes the heat shield, and the parachute is just slowing us down until we can get close enough. So I'm going to fast forward a little bit to when we get closer to the surface.
So when that heat shield deploys, is that like just like it just free floating out there? Is it like more of a controlled descent? Like, do they know where the heat shield is going to land? Like, I was sort of wonder, like, what if it lands on one of the other rovers? Of course, it's not close to one of the other rovers. But is there any control to that, or is it just falling to the surface?
It's as controlled as it can be for something that's being ejected from the rover, but they do have onboard systems, because Perseverance landing is very machine controlled in that it can scan the surface and figure out what the best location is for it to land. So it's not, landing on another rover, landing on a gigantic rock or something like that. And what you're watching here is actually the powered descent. So we're having these retroactive thrusters thrusting in the opposite direction. So we're slowing down enough so that we can have Perseverance land safely down on the surface. And there we go. And that is the moment that everyone was very excited, and I was as well, to see the successful landing.
Yeah, and isn't that moment that right at the end there with the descent vehicle, taking off as it's tethering down the rover, isn't that sort of like the one sort of crucial moment that a lot of people were sort of like the most sort of like, maybe not nervous, maybe nervous is the right word, but sort of like the most crucial moment of the mission?
For sure is, because, as you're entering the atmosphere, obviously that's very concerning if anything's going to go wrong, but it's when you are slamming on the brakes and you're just about to hit that solid surface, that is that crucial moment that you don't know if you're going too fast, if you're going at the right angle. So yes, for sure, that is that is the most pivotal moment of the descent and landing.
Interesting. So everyone that's out there watching, if you have any questions about any of the stuff that you're seeing, throw it into the chat. Over the course of the next half hour, we'll be getting into Mars. But of course, if you have any questions, if you've been dying to ask, we're here. We will get to some questions all over the universe. And of course, on this webpage that you're sharing with us here, Rachel, I also see sounds from Mars. And this is the first ever microphone that has ever been sent to Mars before. So what kind of sounds could we hear?
It is. So, Michael, I don't know if you've listened to this yet, but I will say that it is not particularly exciting, because it does sound like wind that you would hear here on Earth. But you do have to remind yourself that this is actually a Martian breeze. It's a wind that is blowing from a different planet. So it's not just any ordinary wind, it is a Martian wind instead. So I'd highly recommend actually taking a listen and listening to the winds from a different planet.
Yeah, and what will this help us achieve? I guess it's sort of giving us like an extra dimension. We have eyes, we've got video. Is this sort of like the next phase to kind of giving us a complete picture of what's going on Mars?
Exactly. Yeah. So with all these rovers, with Curiosity and Perseverance, they're built almost like they're a human body, right? Because they have brains in the form of a computer system. They have a heating system to keep them warm. They have an arm to reach out and grab things, rovers for legs, all sorts of things like that. But we're also missing that sense of sound and maybe even smell as well. But as we're adding on these different senses, we're getting a more immersive experience of what it's actually like to be on Mars.
Oh, amazing. And I was just listening to some of the people that work on the NASA mission, and there was one of the engineers who was really excited to share with her sister the sounds of Mars, because she's blind and has never been able to kind of see all of these amazing pictures that she has worked on. And so having some sounds to share with her sister, I thought that was really cool, now that we have this extra sense on the red planet.
If there are any aliens, we'll have a microphone ready to interview them.
Absolutely. Let's actually, our first question comes in from Clive. Did you take part in the Send Your Name to Mars on Perseverance? I know that there was many people that you were able to send your name to Mars. If anyone's watching, let us know. Maybe you did as well. Did you send your name to Mars, Rachel?
Yeah, I did. It was a long time ago though, so I can't remember when I did it. But yeah, no, that was a really fun thing to do, just to know that my name would be on Mars. Yeah.
Absolutely. Well, let's get into some of the other stuff because not only do we have some microphones, but we also got some really unique images from this new rover and some of the new designs that they put onto the Perseverance rover.
Yeah, so what you're looking at here is a parachute looking at from the back of the rover, looking upwards as it's ascending. And this is an annotated image, so the words that you're seeing aren't actually there, but it's written in a binary message. And you'll see that it says, "Dare mighty things," which I thought was a very cute message to have encoded. And NASA does have a lot of Easter eggs like this. They have also on the Curiosity rover, if you recall, they actually had JPL written in the treads of the rover. So everywhere they were going on Mars, he was leaving behind JPL, JPL, JPL as Curiosity is roving around. So that was a really cool hidden Easter egg. If you haven't seen it, that the NASA engineers had snuck in into the design.
That is really cool. And of course, that parachute design is really crucial as well, because the Martian atmosphere, the air that we're actually hearing when we listen to those sounds of Mars, is thinner than that on Earth. So, do you know how do they test these things? Because we don't have like a Mars laboratory that we can test these things out. Of course, we have previous missions, but when they're creating these parachutes and creating sort of like the very precise measurements, how do they test that?
So they do it in a very similar way when they tested Ingenuity, because the Mars Helicopter Scout was meant to be a technology demonstration on Mars, especially in that thin atmosphere environment. So it's very much like when we try to make near perfect vacuums here on Earth. Of course, we can't actually get to a perfect vacuum, which is why we send things to space. But the same thing is happening here, where you're trying to evacuate as much stuff or much air out as you can to simulate that really thin atmosphere, because it is a very difficult place to either slow down something like a rover and also getting something to lift off the ground as well.
Yeah. And a question sort of like along those same lines
Mhm.
from Clara, is there fake gravity on a NASA base? So I guess, when it comes to how we test these things in a different kind of environment, even when it comes to astronauts, training to go up onto the ISS, what are sort of the training techniques that are employed to figure some of these problems out?
So a clever solution that they have is, especially for training astronauts for the ISS, they actually just have a gigantic pool that they stick these
Okay.
astronauts into. So they put all their gear, all their suits, and they sink them down to the bottom of the pool and have them walk around almost as if they were in space. Because you know that when you have water, you have buoyancy. It kind of lifts you a little bit, just like it's a lot easier for you to lift your sibling in a pool than it is on the pool deck. The same thing happens underwater. It's a really nice underwater environment to take a swim with your really heavy astronaut gear.
Right. So if anyone wants to try out the Mars simulator, all they need to do is get into a pool and walk around. Is that what you're saying?
Yes, I am. I'll also point out in this image, actually, before we move on, is that this outer ring right here, these are the coordinates for NASA's Jet Propulsion Laboratory as well. So not only does it say "Dare Mighty Things," but they've also given directions to our home planet.
It's almost as if like the engineers that work at JPL are big nerds. This is kind of what you're saying here, isn't it, Rachel?
Oh yeah, no, I bet like they're having a laugh all the time, sneaking little Easter eggs like this in.
Oh, wow. And, I did hear from a lot of the engineers that worked on Perseverance. And, one of the things that really struck me was that because JPL works on lots of other missions going out to space, but the hardest thing they said by far is landing something on Mars. And of course, like the success rate, is not like that great. It's only, it's a little bit better now, but it's only about 50-50 chance of all the things that we've ever sent to Mars have actually landed properly.
Yeah, so it's out of any space agency, all missions sent to Mars, it's 4 out of 10 that have been successful, and that is
Wow.
1% better than an F, which is 39%. So, but NASA's report card seems to be doing pretty well with 5 out of 5.
Absolutely. And, one of the things that I hope everyone that's watching this takes away is that all of those 6 out of 10 times when there was a failure, those were also 6 times that they were able to learn so much from. And, I think like there's a sense that when you fail at something, that's, like the end of the world. But it really is just sort of like the first step to creating these big successes. And I hope people, when they see sort of, the jubilation, that all of the engineers are feeling when they're landing on Mars and they're getting there, they had lots of setbacks before they got to that point, right?
Yeah, and like I always say that there's no failed science experiment ever because you're always gaining something and learning something new to improve for the next one.
Wonderful. We've also got some classes that are joining us watching on our Ask an Astronomer. And our first question from the class comes from, were there any made in Canada parts on the rover?
Ooh, I believe there must have been, but I can't off the top of my head tell you which exact parts it was. But a lot of it was outsourced to different universities. So University of Colorado and Boulder was also a big part. University of Arizona as well. Those are two places that manufacture a lot of these scientific instruments for NASA.
But there is going to be Canadian involvement in the Perseverance mission, isn't it?
Yeah, so in multiple respects. So in terms of Perseverance itself, when we do have the Mars sample return missions where we have spacecraft going to Mars, picking up that sample that Perseverance will have stowed away and bringing it back, on the committee of 10 scientists that will be analyzing it, we do have one that is Dr. Chris Hurd from the University of Alberta, who is a professor of Earth and Ocean Atmospheric Sciences. So he will be one of 10 scientists, lucky scientists, being able to analyze the Mars sample. But we also do have, as part of the larger mission, to going to the Lunar Gateway, so Artemis 3. And I say that that's part of a larger mission because the Lunar Gateway is supposed to be a launching pad for sending humans to Mars eventually for human exploration. And we have two CSA astronauts announced in December of last year that will be joining on that mission, which is very exciting because one of them will be orbiting around the moon. So we'll have our first Canadian astronaut orbiting around the moon in 2024.
Oh, that's going to be super exciting. Our next question, I think, will lead very nicely into some more pictures to share from where Perseverance landed. So Wern is wondering about the significance of Perseverance landing spot and the specific destination that it's going to be driving around.
Sure. So maybe I'll actually bring up this image first. So this is an image from or taken from a 360-degree panorama that Perseverance has taken. And this is specifically a picture of the crater rim of Jezero Crater. And that is where Perseverance's landing site was. And they chose Jezero Crater because it has a very special property in that it looks like there is really great evidence that water was there before, because there's an ancient river delta that is there. And these water features like lake beds and even the minerals that they find around there could have only been brought there or made by water. And so because we're looking for signs of life, we're looking for astrobiology, Perseverance is searching that lake bed because that is our best chance. Because as we know it, the life as we know it requires water. And we're not looking for little green men or aliens that have 2 arms and 2 legs. We are looking for microbial life. So we're hoping that maybe in that sediment, maybe hidden underneath that ancient material is some sort of maybe microbial life, or maybe a tiny amoeba is hiding there.
Yeah, I guess the images that we're going to get back from Perseverance, and I'm only just realizing this now as I'm looking at this amazing picture from inside the crater. So, from this perspective, from this vantage point where Perseverance is, it kind of looks like, there's some mountains in the distance. And if you live in the Lower Mainland, which both of us do, and most of people watching perhaps do as well, you can imagine sort of like looking off to the north and seeing those mountains. But then, of course, you look off to the west and you have that ocean. But of course, where Perseverance is, there's going to be sort of like that rim, as if like there's mountains completely circling them. That's going to be sort of some very unique images, as opposed to perhaps some of the landscapes that Curiosity and Spirit and Opportunity have been taking over the past couple 10, 15 years.
For sure. And I can show a maybe perhaps different image here. That looks a little bit more familiar, perhaps, as to something that Curiosity would see, just because it's a little bit more red, a little bit more orange. And the reason I'm showing you this is because you can see on the left-hand side is a wind-carved rock. And I know that it might not seem very interesting, but what is cool about this is that scale at the bottom, that 50 centimeter scale right there. So that shows you exactly how detailed Perseverance is able to see. And it's I know it's just a rock, but the amount of detail, the price detail that they have in these zoomable cameras that they have on Perseverance is truly amazing. I'm very excited that we have all sorts of these images coming from Perseverance. And this is a 360-degree panorama where those other images or other two images were taken from. And you can see the Perseverance rover stretched down there at the bottom.
Oh wow, these are just incredible images. I'm just like completely awestruck every time that I look at them. And I love the idea that that last image that you just shared, that there was probably some scientist, just like on the edge of their seat, and then was like, "Oh, look over there. What is that?" They only kind of like computer enhance zoom, uh, and found the rock with the wind sort of like carving it out, and just being like, they've never seen anything like that on Mars before. So what other images? Do you have any more images to share from the Perseverance mission so far, Rachel?
Not currently, no.
Well, let's go to another question. Well, let's keep on. If we have questions from any of the viewers, let's get into them, and then we can open it up to any other questions. So when do we project to be able to have some of the samples brought back to Earth? Because you did mention a sample return mission.
Yeah, so we're hoping for the 2030s, and the next batch will be, or the next launch window is in 2022, 2023. But with the Mars sample returns missions, we're hoping for 2026, and that is when we're hoping for that batch of Mars missions to go and pick up the sample. And how that's going to happen is Perseverance is going to stow away that sample in a metal container, and then when we do have a spacecraft that goes and orbits around Mars to pick it up, Perseverance is actually going to launch that sample into space, and hopefully our spacecraft will catch it and then bring it back safely back to Earth.
Oh, wow. That is going to be just amazing. And of course, that takes a lot of planning as well. Can you think of like they're going to be basically putting together some rocks for a future mission that hasn't even been planned yet? Or I guess maybe it's in the beginning of the planning stages, but they haven't built anything and they haven't planned to send anything. But they're like, well, at some point, somebody will pick it up.
Exactly. And it's almost absurd to think that they're launching something into space to be caught by essentially what is going to be a gigantic baseball mitt. But, landing on Mars is also kind of an absurd concept as well. So I have total faith that we'll be able to get that sample back.
I seem to recall a Bugs Bunny cartoon when he was playing a baseball, and it's something like a giant mitt catching a home run ball. This is the first image that comes to
That's
my
also
head.
the image that I was thinking of too.
Another question coming in from the class. Why did we pick Mars? Or why it says, why did you pick Mars? But we, the collective we as scientists, why did we pick Mars as the destination?
That's a great question. So you might think that maybe somewhere like Venus might also be a likely candidate. And Venus is difficult because it is not only incredibly hot, it has a very thick and dense atmosphere, which is why it looks very cloudy when you look at it. The surface is also covered with a bunch of volcanoes and it's very bumpy terrain. So not only can we are not able to look through that really thick atmosphere, it's also going to be very hard for us to control anything that happens on the surface. And with Mars had a very similar history, or at least we have very strong evidence that it does, to having a much wetter and warmer past, just like Earth has now. And we're interested in it because these rocky terrestrial planets of Venus, Earth, and Mars all formed from the same materials, the same building blocks 4.5 billion years ago when our solar system first formed. And so we're hoping that by looking at Mars and seeing how Mars ended up evolving over its lifetime, obviously it ended up very differently looking than Earth does now, but we're hoping to learn a little bit more about our past and maybe even what our future might look like. Hopefully not like a dehydrated place like Mars. Hopefully we'll still have water on our planet, but just learning a bit more about our past history and our future.
Yeah, exactly. And that leads into another great question from Clive, which is if, say, Perseverance does find some evidence of biological life, what would be the next logical step to follow up on that discovery?
Probably very carefully containing that sample first, because you don't know how much of that sample you're going to get. And if there is enough of a sample there that we're able to do analysis on the spot, then something like the laser on board Perseverance would be a great tool to use. So Perseverance has a very similar laser to the one that Curiosity carried, and that was the ChemCam. But Perseverance, being the Curiosity 2.0, has a super cam on top of it, and it does the same thing. So it does science from afar. It can zap a rock sample the size of a pencil point from anywhere from over 7 meters away. And what it does is going to vaporize that sample, turn it into almost like a plasma, and then from that plasma, be able to tell what exactly those chemical constituents are. And we're looking for those kinds of organic materials, organic compounds that we're hoping will be present and indicate some form of life being there.
Rachel, you realize you just said that there is a robot on Mars blasting open a rock with a laser gun.
Yep,
That just sounds so amazing. This is like pure science fiction.
Yeah, it's my favorite instrument on both rovers.
Another question coming in from the class: how likely will it be in the future that humans might live on Mars? I guess first, the question is, when might we see humans at all just walking on the surface? But I guess living would, I guess, be the next logical question to ask. We haven't been living, I guess, longer than, say, a couple of years, even in the International Space Station. But what do you think, Rachel?
Yeah, so I imagine that if we did send people to Mars, and I am positive that we will at some point, I'm sure that they would be living there for some time and won't just be a touch and go kind of thing. Because it takes so many resources and costs to get them there. But the timescale as to when we're going to get people to Mars and when we're going to get people living on Mars is wildly all over the place, depending on who you ask. If you ask a businessman like Elon Musk, it's a lot sooner. He's hoping for 2030s, 2040s. But I think realistically, it might be a little bit further than that, because we want to make sure that we have everything perfect and ready to go. We have enough of information about the environment. We have enough resources able to sustain humans on the surface, because, this very dry and desolate place, we do still need water. We do still need oxygen and food. And those are all three things that we haven't quite figured out how we're going to do yet in a sustainable fashion. But I think 100% yes, we will have people on Mars. It's just a matter of when, and I hope that it's soon.
And it might actually be the journey might be the most difficult part, being in a spacecraft, for 7 to 8 months. But maybe we're all training for that right now, as we're all sort of like in quarantine, right?
Yeah, but it's not even just the 7 to 8 months alone. It's your 7 to 8 months with other people in a combined area as well.
Right. Just a few more minutes left. If you have any last minute questions, get them in. One more question. How multilateral and collaborative are these Mars mission efforts? Is there some form of global cooperation in these pursuits, and other nations have separate programs in tandem?
Absolutely. So the Mars sample returns missions as a whole is mostly a joint cooperation between the European Space Agency and NASA. But then as part of future missions, we also have a few others. We do have the ExoMars Rosalind Franklin mission going as well. So that's a joint operation between the European Space Agency and the Russian Space Agency. We also have a very exciting one from the Japanese Space Agency, and that is looking at both of Mars's moons, and it's actually going to orbit Phobos and actually sample Phobos as well. So I'm really excited for that one, because we're all concentrated on the Martian surface, but no one's looking at the moon. So I'm very happy that the Japanese Space Agency is going to go take a look and see if we can learn a little bit more about one of two of Mars's satellites.
Yeah, that's really interesting. Yeah, so Mars has 2 moons, but they're very different. Like they're not quite like our moon, right?
No, not quite. And I'm glad that they're going now, because Phobos is actually moving towards Mars slowly and slowly. So in about 50 million years, it'll either crash into the surface or break apart into a ring. So I'm happy that we're getting to Phobos before that 50 million year mark.
Interesting. One final question from our class that's watching. Will it be possible to terraform Mars, or maybe even just parts of it? Of course, terraforming, you might need to define first what that exactly means. To
Sure. So we're
something.
modifying the surface in a way that makes it more livable and habitable for humans. And the reason why this is important is because Mars doesn't exactly have the same kind of climate, the same kind of weather that we do here on Earth. On Earth, we have a lovely atmosphere, we have weather, and we have winds and water and rains to erode the surface and change what the surface of our our Earth looks like. And with Mars, they do have it has weather, it has climate, but it has it in kind of a different form. So it has a lot of dust storms, and that makes it very difficult for human habitation. And so we're hoping for terraforming Mars to be making it more green, making it more livable, having water in different places. And there are many ideas of doing so. I like to bring up Elon's method, which is to bomb the surface. And that idea is to basically emit a lot of carbon dioxide and having that greenhouse effect that we don't love here on Earth, but having that speed up the heating up of Mars, because the average temperature on Mars is negative 60 degrees Celsius. And the average temperature here on Earth is 14 degrees Celsius. So we want to warm up the planet a little bit before we can live on it.
Yeah, absolutely. Well, we just have our last minute left, Rachel, as we go into our third month of the year. Wow, it's March already. We're getting ready for spring break. We are open here. So on the weekends, you can buy a ticket. You can come through our observatory, come through our gallery space. And we are also doing lots of online sessions. So if you would like to get in on our online sessions, you can go to our website. You can even have a private session with you, Rachel, because Rachel, you've been doing some sessions with some classes. I know that there are some classes watching that would like to ask you some questions. We got a whole bunch of questions. Even have a list. Could pick one, actually, one final question for you, Rachel. We were talking about moons. One really cool question from the class. Or the list of questions we got from the class. Can a moon have a moon? So you talked about Mars having two moons. Mm-hmm. So a planet having two moons, but can a moon have its own moon?
So not quite. And that the only reason for that is because of definitions from the International Astronomical Union. And so a moon is a natural satellite or a body that orbits another planet. And so when I say moon, I'm talking about natural satellites because the only moon that we have really is Earth's moon, or Earth's only natural satellite. And so when we say a moon having a moon, it's not quite, because it would be a moon orbiting some other more massive object that would be a planet.
And what would you even call that? A moon? A moon 2.0?
Yeah.
Moon squared. So if you want to get in on our online sessions or have we call it a Beam Us In session, I can check that out on our website. And hopefully we'll be talking to your class. But we'll also be right back here on YouTube in 2 weeks, Thursday at 2 o'clock. Until then, see you next time.